Right, on the bench we have a steering box of a tractor. And the way these work is you have the steering column which fits inside this shaft over here, which bolts onto here. You have a shaft goes down in there, and you turn the steering wheel and it turns this, which moves a rod which steers your tractor. Now, the issue we have, and this applies to many tractors, many older tractors I should say, the steering column is part of the bearing, and you have a bottom race which goes here, and you have ball bearings or your rollers, whatever it's got. I said it looks like ball bearings in this case. Some have taper rollers. So your bottom race is here, and this is the top race is machined into the column itself, and this race fits inside here at the bottom, and then your ball bearings are in there, whatever. Anyway, so that makes up your bearing, and it's the same for the top. And what you can see here is it's badly corroded, and what happens to these is water gets in over time and it gets down into the bottom here, and it basically rots the bearings. They rust away. Here's the bottom shell. As you can see, it's all chewed up. This is the top one, which is in better condition, because it wasn't sitting in water. So this fits into a cutout into the bottom of the box. Now, what we normally do is we find a taper roller bearing set. A modern. You can't get the bearings. Well, it's damaged anyway. Half of it's damaged. So we put these in a taper roller set, and we machine the end of this shaft to take that side of the bearing, and we fit this race into the bottom of the box. But this race, in this case, is slightly bigger than the original. So we need to machine out the bearing housing in this casting at the bottom, and the same would go for the top. But that's what I was asked to do. Well, I've got a slightly different idea. What are we talking? Dum-de-dum-de-dum. Let's have a look at this one. .875 imperial bearing, which is what we would expect. .875, and our new bearing housing is 1.890. 1.981. 1.891. So Alexa, 1891 minus...
I don't know that one.
Oh, that's a lot of help. Okay. So we got 91.75. So that would be 8. That would be 6. 16 thou. So we've got 4 thou per side to remove. So I'm going to double check that. Simple quick check is to take off verniers, zero it, turned it off, zero it, put it into thou, imperial rather. I got 16.5. Okay, so we're on the money. Let's look at that in metric. So change that to metric. Zero. Zero point 42. 0.41. 0.4. Okay, so not 16 thou or 0.4 millimeters. Now, can we machine the outside of this bearing 0.2 millimeters? What would that leave us? Oh, come on. That thinnest part of that race is 1.9 millimeters. I think that's doable. So now we need to figure out a way of holding the bearing so we can machine it. Yeah, I think that's what we're going to do. Okay, I'll come back to you.